All right, now let's move on to some examples. Suppose you select a person at random from your campus. Which of these are mutually exclusive? And when they say mutually exclusive, you want to think of the same term, it as just a synonym for disjoint events. So they'll be used interchangeably. All right. Has ridden a roller coaster, has ridden a Ferris wheel. Does one prevent the other from happening, right? In fact, you might have people who have both ridden roller coasters and Ferris wheel. So I would say these are non-disjoint or not mutually exclusive. Listens to Beatles music, listens to Lady Gaga. Well, there's nothing that prevents people from doing both, right? So I think even I have both songs on my, iTunes. Has brown eyes, has brown hair. Well, here too, you could have both brown eyes and brown hair, or you could have just brown eyes, but other colored hair. And you could have just brown hair or other colored eyes, right? So also non-disjoint. Is left-handed and is right-handed. This one, your dominant hand is probably just one or the other, right? And so I would say this is probably disjoint. What pops into mind right now are the ambidextrous people, but usually ambidextrous people, even them, they sort of prefer one hand versus the other, usually. So I'll just count it as disjoint for now. Has had chicken pox, has never had chicken pox. Now this one is definitely disjoint because you can't both have had it and not have had it at the same time. Okay, suppose you flipped a coin 3 times. What is the probability that you will have a combination of 1 heads and 2 tails? Well, this, you have to sort of remember the lesson from last time as well as knowing the addition rule. Because first we have to figure out what the entire sample space looks like, the sort of whole square, right? And so the whole square would be, so if I flipped a coin 3 times, that would mean that's 2 to the 3rd power, which is 8, right? So first flip, second flip, third flip. And so half of these 8, the first one needs to be heads. Half of them, the first one needs to be tails. So I'm just going to start off with that. Second one, half of these have to be heads. Half of these have to be tails. Half of these have to be heads, half of these have to be tails. Now, half of these have to be heads, and the other half is tails. Same thing here. And I don't know if you see the pattern, but it sort of just cuts in half every single time. And always the last one, it's half of 2. It's always going to alternate heads, tails, heads, tails. All right. So now we know that each of these are a probability of 1/8, right? And now we could use the addition rule to figure out what is the probability that you'll have a combination of 1 heads and 2 tails. Because we could just find all the 1 heads and 2 tails, and we add those probabilities together because these 3 things are disjoint events. You can't have both heads, tails, tails, and tails, heads, tails at the same time, nor can you have tails, tails, heads at the same time as either of these 2. So we have the probability of 1 heads and 2 tails equals 3/8. All right. Anne and Bill are planning their engagement party. The room will hold 200 people, so they agree that Anne will invite 100 friends and Bill will invite 100 friends. Everyone invited to the party showed up, but only 140 people turned up. What must have happened? Well, it might be helpful to think about this as a picture. Here are all the people that Anne invited, and here are all the people that Bill invited, and together it's going to be 140 people. That's the entire space. But there's some portion of their friends that must have overlapped, right? And so we're trying to figure that out. Now, right now we're looking at frequency instead of percentages, but obviously you could turn these into percentages if you want, but I'm just going to keep it in frequency form. So really we're looking for the probability of A or B, that they're friends with either Anne or Bill or both of them, right? That's fine if you're friends with both of them. And that's going to be the probability of A plus the probability of B minus the probability of A and B. Now, one way you could turn this probability statement into like a absolute statement is just multiply everything by the total number of people, right? But I'm just going to keep it as this. All right, so we have 100 of Anne's friends, 100 of Bill's friends, and we don't know the overlap. But we do know that 140 people showed up eventually. We do know that part, right? So the way you could do this is just divide everything by 200, because that's the total number invited. But that's neither here nor there. All right. And so if we do this, and we have 200 minus probability of A minus A and B, I probably want to add this to both sides so that I can make it positive. I probably want to subtract this from both sides. So I'm just going to do that right here. 200 minus 140, and that's going to be 60. So the probability of A and B, or the frequency in this case of A and B, is 60. And let's see if that makes sense. So if 60 people are here, then how many people did Anne know who are the people who just Anne knows, right? That's 40 people. And same with Bill, because he also invited 100 people, and 60 of them also know Anne, right? So when you add all of these up, it makes 140, right? And so, ta-da. Okay, so in your community, 80% of households own car insurance or homeowners insurance. 40% carry homeowners insurance, and 50% own car insurance. If a household is picked at random, what is the probability that they have both types of insurance? Once again, we could use the general addition rule to figure this out, because we know the probability that the household owns both car insurance. Not both. We don't know the probability that they have both, but we do know the probability that they either own car or home, right? They might own both, we don't know, but they at least own one, and that's 80%. But 40% own just homeowners insurance, and 50% own just car insurance. And we want to know what's the probability that they own both types of insurance. So I'll put in, I'll write the general version. Doesn't matter which, whether P of C or P of H comes first, minus the probability of C and H. Right? And so if I put in my numbers here, I add this to both sides, I subtract this from both sides, I'll get and that gives me 10%. So 10% own both types of insurance.